千里之行，始于足下。A journey of 1,000 miles begins beneath the feet. We now gather in the Tao to travel the journey together. Welcome to Tao Talks with Derek Lin, where we delve deeply into the Daodejing by Lao Tzu. So let me zoom in on that and talk about the flaw or the missing pieces in the great perfection that we discuss at the macro level. Let me use a slide to make that easy to understand. This slide is called Human Understanding of Nature. On the left-hand side, you're going to see the different theories. These are unknown to the ancients. These are, again, things that match the Tao very well, and we can use them as examples for the Tao. So theories on the left-hand side. On the right-hand side, we have the character Che. Remember, that's a flaw or imperfection in terms of something that is missing. In this case, understanding or knowledge that is missing. I want to start with Newton's laws of motion. This was a grand achievement. The graphic that I have here, this is Newton's cradle, where you have the striking balls that transfer the kinetic energy from the ball that's being struck to the very end of it. And this illustrates Newton's laws of motion. You know, for every action, there's an equal and opposite reaction. What is the flaw? What is the imperfection here? Well, it is remarkable how well Newtonian physics work. We can use nothing but Newtonian equations to manage flights within the solar system, to predict with great accuracy the journey to the moon and back, the trajectory or the orbits of man-made objects, satellites, rockets, the space shuttle, the International Space Station. All of these can be calculated to great precision with Newton's laws of motion. Where they don't work is when velocities approach light speed. That's the reason why Newton's equations work so well for us within the solar system, because we rarely, except in laboratory conditions, we usually never get anywhere close to the speed of light. Not even our most advanced rockets, none of it can even get close to the speed of light. So it's typically not a problem. But when we observe natural phenomena, when we make measurements of particles that move very fast, close to the speed of light, we know that Newton's laws of motion no longer apply. So there's definitely gaps. There's a flaw. There's missing pieces of understanding using that theory. So then it has to be supplanted by something better. Einstein's theory of relativity. So this was cause for celebration. It was a watershed moment. It was a revolution in physics when Einstein's theory of relativity perfectly captures what happens to objects as they get closer and closer to the speed of light. And the graphic that I have to represent for that, no big surprise, it's Einstein's famous equation. E is equal to mc squared, where E is energy. There's the equal sign. M is the mass. C is the speed of light, which is a constant. And then C squared. So that is the equation. Relativity has withstood the test of time and works extremely well under conditions where Newtonian physics would not work as well. But Einstein's theory of relativity also is flawed or imperfect, or I should say incomplete. Relativity, the big problem there is that it cannot describe what happens at the quantum scale. For that, we need something different. And Newton's laws of motion also do not describe what happens on the quantum scale, where it is all about wave functions that collapse upon measurement. So quantum mechanics, set of equations that are proven to work extremely well at the quantum level. And the graphic that I have for that, this is a fanciful depiction of entangled particles in quantum mechanics. The idea is that two particles that are entangled in the quantum jargon, they can be separated by light years. And yet, when what happens to one of the entangled pair will instantly, immediately be reflected at the other entangled part of the pair, which appears to violate relativity in that the speed of light should be the maximum speed limit, but not for entangled pairs. Anyhow, it doesn't actually look like that. Actual entangled particles do not look like special effects. They actually look very boring and would not make interesting graphics. So that's just a representation. Now, what is the flaw for quantum mechanics? Well, it's also imperfect. It's also incomplete because there's nothing to tie it together. There's no theory of gravity, for instance, to tie everything together for the grand unified theory of physics. So when's that going to happen? Well, perhaps if we have another genius like Newton or Einstein, we can hope to have the GUT, the gut, the grand unified theory. Right now, the foremost candidate for that is string theory, and that's far from proven. So what I'm trying to say here is that at every level of human understanding about the cosmos, we have flaws. We have things that we don't understand in our theories. Not in the universe itself, not in the Tao, in the human understanding of it. So, we are missing a piece of understanding. We still are. Our meeting has come to an end, but the journey continues on. Let us travel safely. Until next time, may the Tao fill you with peace and happiness.